Hey everyone, and welcome back to All About AI Tech. Today, I'm incredibly excited to dive into a topic that's absolutely revolutionizing the search landscape, GraphRAG. If you're in the world of AI, chances are you've already heard the buzz. But beyond the hype, GraphRAG represents a profound shift in how we interact with and extract knowledge from data. In this video, we'll break down what makes GraphRAG so powerful, its origins, and why it's set to become the future of intelligent search. Let's start with the foundation. Retrieval Augmented Generation, or RAG. Now, RAG itself was a game changer. It allowed us to ground large language models, or LLMs, in real-world data, giving us more control over responses and making it easier to provide up-to-date information. Instead of relying solely on information contained in an LLM's training set, we could provide proprietary and dynamically changing data. But RAG often falls short when dealing with complex questions or specialized fields. It can miss crucial connections, or give us generic answers when we need deep insights. Think of it like searching for a specific product feature in a dense technical manual. RAG might surface the entire manual as relevant, leaving you to do the heavy lifting of digging through hundreds of pages. And that's where graphs come in. No, not bar graphs or pie charts in this case. Here, I'm talking about knowledge graphs. Think of them as intelligent maps of information. Knowledge graphs capture entities and relationships between them, a bit like a Wikipedia article on steroids. Even Google uses an enormous graph powering its search. Imagine a network of concepts where everything is connected in a meaningful way. Suddenly, finding that elusive product feature becomes as easy as following a path. You're not just matching keywords, you're understanding the context, and that's why we have GraphRAG. GraphRAG elevates the RAG workflow by adding depth and context. It's not just about retrieving similar chunks of text, it's about retrieving interconnected knowledge. With GraphRAG, an LLM is used to create a knowledge graph from all the documents in its search index. Think of it like an AI automatically building these concepts and their relationships. We then use this knowledge graph for retrieval, meaning the LLM can then connect the dots between information in different documents, allowing the system to answer more complete and precise questions using the graph. The result? More accurate, more comprehensive, and more diverse answers. We're talking about an AI that can actually understand what is going on in your data, not just what is semantically similar to what you searched, or about the topic you searched for. GraphRAG shows substantial improvement over traditional RAG systems, and GraphRAG can provide up to 14% better results than traditional RAG on some benchmarks. For instance, consider you are querying an extensive database of news articles on a specific event. GraphRAG can pull together information from different sources, connecting people, organizations, and locations to give you a holistic view of the whole event with specific sources and facts. A traditional RAG system might simply give you a list of articles containing similar keywords. Microsoft has been leading the charge here, releasing their GraphRAG implementation as open source. They've made it incredibly easy to get started, and the results are impressive. Using GraphRAG, question answering on complex datasets, such as finding topics and themes in thousands of documents, was significantly better than using plain RAG. What's even more interesting, not only does GraphRAG provide more accurate answers, it also does so with less resources, using 77% fewer tokens than traditional RAG. And while Microsoft has made a huge contribution to the development of GraphRAG, it is not the only way to implement it. There are a number of other implementations and tools that have emerged, each with its own strengths and weaknesses. LlamaIndex, for example, integrates Microsoft's GraphRAG for efficient knowledge synthesis, retrieval, and enhanced LLM utilization. Other implementations and systems include efforts from innovative companies like Nebula Graph and Neo4j who are working specifically on this problem, as well as open-source frameworks like LangChain, which allow for multiple flexible implementations of GraphRAG. From the software engineering perspective, there are two main options for implementing GraphRAG: using a separate graph database or integrating graph functionality directly in the vector database that's already a part of your RAG stack. The potential of GraphRAG spans a wide range of industries and use cases. In healthcare, it can analyze patient records, medical literature, and clinical trials to assist doctors in making informed diagnostic and treatment decisions. In finance, GraphRAG can assess market trends, economic indicators, and company financials to provide valuable insights for investment strategies. Legal professionals can use it to analyze legal cases, regulations, and precedents for comprehensive research. Customer service bots powered by GraphRAG can offer more accurate and contextually relevant responses, improving customer satisfaction and resolution times. Educational platforms can utilize GraphRAG to provide students with personalized learning pathways and richer, more interconnected study material. The key here is the connection. Any area where understanding the relationships between data is crucial will benefit. Now, while GraphRAG is incredibly powerful, it's important to acknowledge the challenges. Building and maintaining a comprehensive knowledge graph can be complex, requiring expertise in data integration, entity resolution, and schema definition. For example, an entity might appear with slightly different formatting in various documents. Say, Silicon Valley Bank and Silicon Bank. You need to merge these two different entities from a text perspective. A human being can see they are the same, but it is challenging for an AI to understand. Integrating GraphRAG with existing systems can also require significant development effort, especially if it involves new data stores and query languages. Scaling graph databases and LLMs to handle large datasets can also pose computational and cost challenges, owing to the resource-intensive nature of complex search operations involved. So, what are the best practices for implementing GraphRAG successfully? First, focus on building a high-quality knowledge graph that accurately represents the entities and relationships within your domain, and make sure those entities are useful and relevant for the types of queries you or your users wish to conduct. Second, consider using pre-existing knowledge bases or ontologies, like Wikidata, to jumpstart your graph construction process to get around some of the issues with having bad quality or inadequate data. Third, carefully evaluate the complexity versus value of adding a separate graph database. If your vector store supports graph connections, edges between vectors, and can do multi-hop traversals, then this approach has many fewer moving parts, which means easier scaling and better data quality. Next, prioritize the use of short, direct connection paths between entities and graph to avoid long, deep graph traversals and the cascading or compounding errors they could introduce. Then, optimize retrieval and query mechanisms to efficiently extract relevant entities, relationships, and associated information from the knowledge graph that can supplement the standard vector search, enabling it to make non-semantic connections between documents and other chunks of information. For example, you can integrate keyword search or text search if you find your users need exact matching of terms rather than semantic search on topics. This can be a much easier engineering task than embedding and retrieving every keyword from your dataset using a vector store and LLM. You could also use an LLM to turn a user's query into a graph query and then use that query in your knowledge graph. Finally, prioritize a seamless user experience and create intuitive interfaces that allow analysts, end users, and other non-technical personnel to interact with and derive insights from GraphRAG-powered applications without the need to know or use graph query languages. Where is GraphRAG headed? The convergence of knowledge graphs and LLMs is just getting started, and its impact in 2025 and beyond is expected to transform how decision-making is done. One trend we can look forward to is the emergence of more efficient and scalable implementations of GraphRAG. For example, those that use data structures that optimize how LLMs are used by reducing their compute needs and speeding up queries. Another trend will be enhanced LLM tools to further empower the automation and augmentation of knowledge graph construction, management, and integration, as well as the query and retrieval processes. And finally, AI systems in general are moving in a hybrid direction, allowing use cases and specific applications to choose the correct type of retrieval method given what we know about the user's intent and the data itself. If the user is asking for exact text matching, then we would use a text search. Or if a user is requesting an overview of the main themes, then a knowledge graph would be ideal. Along the same lines, if the response requires data from a structured database, such as from a data warehouse, a GraphRAG approach is also likely an enabling factor. Finally, many knowledge graphs are being built specifically for GraphRAG, using standardized data schemas to enable LLMs and related technologies to infer structure and automate search and retrieval strategies. The end result would be more easily transferable, scalable, reusable, and verifiable AI systems that can connect more readily with existing and future technologies. For those eager to delve deeper into GraphRAG, I've included a number of resources in the show notes below to help get you started. The material, curated from various repositories, articles, and journals, should provide clear and well-defined starting points for beginning your own GraphRAG projects. You will find links to code and datasets such as the one we used in this video, along with other helpful technical information. This additional info is intended to complement the ideas in this guide and give you a thorough foundation for using GraphRAG successfully. There are links to some hands-on tutorials on getting started quickly and easily with GraphRAG in LangChain and LlamaIndex, including with popular vector and graph databases such as DataStax AstraDB, NebulaGraph, and others. There are also pointers to projects that showcase easy and scalable implementations of GraphRAG across multiple use cases. And finally, I'm excited to share with you the latest research and innovations in the GraphRAG space that address some of the challenges noted above, specifically recent methods using LLMs themselves to improve GraphRAG workflows by automatically enriching knowledge graph structures and enhancing query and retrieval accuracy while reducing overhead and associated costs. I am incredibly grateful for the support and encouragement I've received from all of you. As we continue to unpack the complexities of GraphRAG, I'd love to hear from you about how it's going for you with GraphRAG and how you're using it to build next-generation AI applications. Please feel free to share your thoughts and ideas in the comments or via email. Thanks for your patience, and see you soon. Remember to like this article, subscribe to this channel, and sign up to get notified when we release our next video.